This is a pretty standard equivalent resistance problem here in number 30. You have 2 points here, sort of the top and the bottom of the circuit here. I believe the problem labels at point A and B. And what you'd like to know is if you replace this entire resistor network with a single resistor, what would the equivalent resistance be? So what this requires then is for you to look at the electrical orientation across all the resistors here to see if you can figure out some commonalities in the way they're joined here to reduce them down a bit. So I look immediately at this thing here and see the 10 and the 30. These two things are in series right there. So this can be replaced with a single resistor of 40 ohms because resistors in series just add together. That'll be a 40 ohm. So it's probably a good idea then at this point to go ahead and redraw the circuit reflecting what you've just done. So now you have a circuit that's going to look like this and like this. All these other two resistors here have not been touched. They're still there. So that's a 40, this is a 60, and that's a 10. So that's what your circuit has now become. So you sort of go from one to the other. Now we'll go down here and take another step. If I look at this system carefully here, I notice the 40 and 60 are in parallel. So that can be replaced now with a single resistor like this that goes down like that and goes down like that. Here's a 10 ohm resistor in here, and resistors in parallel combined with that weird inverse law here. So I'll say that this resistor here is going to have a resistance of 1 over 40 plus 1 over 60. And I'll look something like this there. There's a 1 over 40 plus a 1 over 60. Sorry, I didn't realize I was off camera right there. So in either case, we have this circuit now. We recognize the 40 and 60 are in parallel. The 10 is still there. The 40 and 60 combined to be this single resistor in parallel right here, and you can calculate exactly what that's going to be yourself. But now what I have is two resistors in series like this, so I can take my fourth and final step over this way to realize that the total resistance I'm going to get here is just going to be 10 plus R. This is going to be my R equivalent right here. So the 10 persists in there. You can't do anything about that. You'll get your R from this equation right here. So whatever you get for this, add it to 10. That'll be the answer to the problem.